My name is Aditya Gaikwad, and I am from the ENTC department from the Division D final year. And the topic that I am going to explain right now is RTP header structure and key fields. So let's start with the introduction of the RTP. RTP stands for the Real-Time Transport Protocol, which is used for delivering audio and video over IP networks. So the reason why RTP is used is because there are some key advantages which wins it over the other protocols like TCP and others. So the key features are, the first is it has low latency. Second, the RTP uses timestamps and sequence numbers to reorder packets and adjust for network variations. And the other feature is, like, unlike TCP, RTP does not retransmit packets, making it suitable for real-time application where timeliness is more critical than accuracy. Now, the purpose of the RTP is to provide end-to-end network transfer from real data, and RTP also provides multicasting, which from which we can send the data to a particular targeted group. So now let's look at the RTP header. So the RTP packet consists of two main parts. First is the header, second is the payload. First, the header contains the information about the payload, which consists of 12 bytes minimum. And the second is the payload, which contains the actual data that is to be transmitted from the transmitter to the sender. So the diagram which we can see on the screen is the header structure, which consists of the variable fields. So some of the fields are version, which consists of 2 bits, padding, which is of 1 bit, extension, which is also of 1 bit, then CRSC count, CRSC count, which contains 4 bits, then marker, payload type, sequence number, SSRC identifier, and CSRC identifier. So this pretty much the RTP header pretty much contains all these fields. Now the key fields, which describes the actual payload. The first one is version, which states the RTP version, which is currently used as 2. So the value is also set as 2. Now the padding is usually of 1 bit, which indicates the extra padding in the end. Third is the extension field, which is also 1 bit, which signals the presence of an extension header. Next is the CSRC count, which consists of 4 bits. This tells about the contributing sources from the transmitter. Second is the marker, which highlights significant events like time boundary, frame boundaries, and etc. Then comes the payload type, which consists of 7 bits, which indicates the format of the RTP payload, whether it is audio or video or any other data type. Next comes the sequence number, which consists of 16 bits. It detects the lost packets and helps in reordering to the sender, which is an advantage which makes RTP stand over the other protocols. Then comes the timestamp. The timestamp consists of 32 bits, which helps synchronization and jitter compensation. Now the jitter compensation is one of the important thing which in the RTP, as there are various time as the packets take different routes, so the receiver receives the time steps at the different time, which RTP uses which is used to reorder the packets from the transmitter and adjust for network variations. So next one is the SSRC. Now the SSRC identifies the source of the RTP stream. Next is the CSRC, which identifies the contributing sources in the mix stream, which In the first, we must have shown in the CSRC count from the transmitter, which tells about the um, contributing sources in the stream. Now the applications of RTP, there is a various spectrum of applications. For example, we use like Google Meets and Zoom meetings that uses the RTP protocol for real-time transmission of the audio and video both at the same time. Second is the online gaming and multiplayer communication, which is it is also used in voice chats in apps like Discord and other and video streaming services like YouTube, Netflix, Prime Video also use this type of protocol to maintain synchronization between audio and video streams. So that's pretty much covers the RTP header structure and its key fields. Thank you very much.